All right, this is 7C notes. This is our second day on graphing these rational functions. So now you're still going to be using these same guidelines when you go to graph these. And you might be asking yourself, well, how do I know when to use the guidelines and when to use the parent points? So if your function looks like this, a single fraction, this is when you're going to use the guidelines. And if it's in general form, so not a single fraction, that's when you're going to use the parent points. Okay? Alright, so, like I said, we're using the same guidelines that we use in 7B notes. So let's look at our first example. What we're dealing with today is when things are not what we expect them to be. Okay? So we've dealt so far only with horizontal and vertical asymptotes. So let's look at a case when we're not going to have a horizontal or might not necessarily have one or the other. Alright, we still want to start off these always by factoring the numerator and the denominator. So my numerator has a GCF of x, and my denominator is just x plus 2. Alright, so looking back at your guidelines here again if you need to, a whole. A whole is when you have a common factor. We don't have a common factor, so I don't have a whole. My vertical asymptotes, it's the zeros of the denominator. So that means x equals negative 2. Alright, horizontal asymptote. Remember, that's when we match up the degrees. So the highest degree in this is x squared. So 1x squared. And on the bottom, notice I don't have an x squared, so I put in a 0 placeholder. Alright, well this simplifies to 1 over 0, which is undefined. So that means we don't have a horizontal asymptote. So now when you don't have a horizontal asymptote, it may have what we call a slant asymptote. So let's go back and look at the definition of a slant asymptote. So a slant asymptote occurs when the degree of the numerator is exactly one more than the degree of the denominator. So in our case, this is actually our problem. Okay, close. All right, but here the degree of the numerator is 2 and the degree of the denominator is 1. So this is when we're going to have a slant asymptote. And you find a slant asymptote by doing long division. So let's do that. So you might want to get a sheet of scrap paper here where you can have some more room to work. Alright, so we're going to divide x plus 2 into x squared minus x. Well, x into x squared, I need another x. Distribute, you get x squared plus 2x. I'm subtracting, so remember I changed my signs, which gives me minus 3x. X goes into negative 3x minus 3 times. Alright, and I don't care about the remainder, but I have to have a remainder. I just don't care what the remainder is. Because if it doesn't have a remainder, then that factor would be a whole. But since it does have a remainder, then that means this is my slant asymptote. So your slant asymptote, it's always going to be linear, is y equals x minus 3. So instead of having a horizontal asymptote, it's going to have a slant asymptote. Alright, so let's go back and graph those asymptotes. And we'll find, let's get rid of this, we'll have some room. Okay, so let's go ahead and find my x-intercepts. That's the zeros of my numerator. So I've got x, so I've got 0, 0, and then I've got 1, 0. And then my y-intercept, plug 0 in for all my x's, so it's going to be 0, 0. Okay, so we've found all our information, so let's graph our asymptote. So we're going to graph an asymptote at x equals negative 2. Now remember, because I have one vertical asymptote, that means my graph is going to have 2 pieces. And then graph your slant asymptote. We're just graphing that line. So negative 3 is my y-intercept, and this has a slope of 1. And you want to carry these asymptotes all the way off your graph. And always feel free, if you don't like the graph paper that I provide, you can always use use your own graph paper. Okay, so there's our asymptote. So that means this graph is going to have two pieces. That means I'm either going to be here and here, or in these two areas. Okay, we're going to have two pieces to our graph. All right, let's graph our points that we have and just see what else we need. All right, so we got 0, 0, and then I've got 1, 0. It doesn't tell me much there, okay? All right. Now I am going to be able to rotate these points down here, and I'll do that in a minute. All right, we need to find some other points here, and then I can rotate to get the other piece of my graph. Since it's up, I know one piece is up here, my other piece is going to be down in this area. Okay, so let's plug in x equals -1. All right, so my y is going to be what? -1 minus 2 over 1. So that's going to be 2. 1, 2. I'm sorry, -1, 2. So -1, 2. All right. Now I got to figure out what it's doing down here. So let's put in +1/2. So x equals 1/2. Y is going to equal, plug in 1/2. So what are we going to get? We're going to get 1/2. 1/2 minus 1 is -1/2. And then 1/2 plus 2 is 2.5, which is 5/2. All right, simplify that, and you should get -1/10. So at 1/2, it's going down just a bit. All right, let's plug in one more point, and then we're done with half of it. Let's plug in x equals 2. X equals 2. All right, so it's going to be y equals 2 times 2 minus 1, which is 1, over 2 plus 2, which is 4. So 2/4 is 1/2. So at 2, 1/2. Okay, so this piece of the graph, remember, respect our asymptotes, it's coming and it's doing like that. All right, so let's get that other piece now. All right, so we're going to rotate these points. Remember, I'm counting from where these two asymptotes intersect. So if I'm going to rotate this point, it's going to be 1, right 1, up 1, 2, 4, 5, 6, 7. So I'm going to go left 1, down 7. 1, 2, 4, 5, 6, 7. All right, let's rotate this point. It's 2, 1, 2, 3, 4, 5. So 2, 1, 2, 3, 4, 5. This point, all right, the little drop is going to be like up a little bit. And then finally, 2.5. So this was what? 1, 2, 3, 4. 1, 2, 3, 4, 5.5. 1, 2, 3, 4. 1, 2, 3, 4, 5.5. All right, so there's the second piece of my graph. Okay, so that's what a slant asymptote looks like. And this one does have rotational symmetry. Pretty much the only ones that don't have rotational symmetry is when they have those two vertical asymptotes. All right, so that's an example of a slant asymptote. Now I'm not going to ask you for the domain and range on these because we can't find, without the use of a calculator at this point, the max and the mins of these things. So I'm not going to ask you for domain and range on something like this. All right, let's look at another example. Are there any surprises? Well, yeah, I guess you think, well, yeah, there's going to be a surprise happening here, otherwise I wouldn't have asked the question. All right, so first of all, let me show you what this looks like on a graphing calculator. If you were to graph this, all right, it looks like the following. So look at this thing. So you notice it looks like it has a vertical asymptote and then a horizontal asymptote, but we're crossing that horizontal asymptote. Remember, in the body of the graph, we can cross a horizontal asymptote. The end behaviors won't cross that horizontal asymptote. All right, what's special about this is making this particular one do this. Let's look at when we factor this thing. So let's go back and factor it. All right, so let's factor the numerator. If I pull out a 3, all right, GCF of 3, that's going to leave me with x squared minus x minus 2 over the bottom is going to factor what multiplies to give you 16 but adds to give you 8. It's going to be x plus 4, x plus 4. Notice this is a perfect square trinomial. That's what's making that weird stuff go on this one. So you've got to learn to recognize, okay, when you have a perfect square trinomial, the same factor twice in the denominator, that's where it's going to have that interesting little, one side of it's going to have that interesting little jump across the asymptote and jump back up. All right, let's finish factoring. What multiplies to give you negative 2 but has a difference of negative 1, so x minus 2, x plus 1. Okay. All right, whole. Notice we don't have a whole. There's no common factor, so there's no whole. All right, there is a vertical asymptote at x equals negative 4. All right, horizontal asymptote. Let's go back to this, right? Same degrees. If we simplify that, we're going to get y equals 3. Is my horizontal asymptote. If you have a horizontal asymptote, you can't have a slant asymptote. You can only have one or the other. All right, let's find our x-intercepts, zeros of the numerator. So that means 2, 0, and negative 1, 0. And the y-intercepts, plug in 0 for x. That's going to leave us with this. So 0, negative. Let's reduce that 3/8. All right, so start there. All right, so we're going to do the same thing we've done before. We're going to graph those asymptotes first. So x equals negative 4. 1, 2, 3, 4. Dot these in. That helps with my graph. Y equals 3. Okay. All right, let's graph what we have and figure out what we need to plug in. Like I said, unfortunately, these kind of graphs, you're going to have to plug in more points to find what you need. Okay, let's graph what we have. We've got 2, 0. So there's a point. And unfortunately, we're not going to be able to rotate this thing. You saw that before. This doesn't have rotational symmetry. And it's all about doing enough of these to recognize these patterns. And then negative 1, 0. Okay, so this is we're going to have to, like I said, this is still going to have two pieces because I have one vertical asymptote. So we've got to figure out where those two pieces are. So we're going to have to plug in enough values to help us figure out where our pieces are. Okay, so I'm going to, since I've got some stuff over here, let's put in else. We also know that we have 0, negative 3/8, so that's almost a half there. Okay. All right, so let's see what's happening here. All right, so I need to plug in at least a couple of points. I need to figure out what's going on over in this region, and then what's going to go on over here to the right of my number. So let's plug in first x equals negative 2. So what am I going to get? Y equals 3. Negative 2 minus 2 is negative 4. Negative 2 plus 1 is negative 1. Over negative 2 plus 4, which is 2 squared, which is 4. All right, clean that up, and you should be getting positive 3. All right, so let's graph negative 2, 3, and you can see that it's crossing. That's where it's touching my horizontal asymptote. So it's going to continue up in this direction now. All right, it's going to then drop down. Now we're going to figure out what's happening over here. So let's put in, I use x equals 4. So what do we got? Y is equal to 3. 4 minus 2 is 2. 4 plus 1 is 5. Over 4 plus 4 is 8 squared is 64. This gives me 30 over 64, which reduces to 15 over 32. All right, so it's a little bit less than half. So 4, 1, 2, 3, 4, and a little bit less than half. All right, so this thing is starting to go back up. And if you want to put in more points, this is going to start approaching that asymptote. So it's going to respect the vertical asymptote, come down, drop down, then go back up. And then at the end behavior, it's going to start to respect that horizontal asymptote. the end behavior will never cross that horizontal asymptote. But remember, the body of the graph, it can do that. So the weird stuff that's going on. Okay, this is only half our graph though. All right, so we got to figure out what's going on this side of the graph over here. So this is where we're going to have to plug in more points. Okay, so let's give myself some room to do that. I'm going to get rid of this. So you can see where you might need a scrap sheet of paper keep. Like I said, this is going to require a little bit extra work because you have to plug in those values. And we're not using a graphing calculator. All right, so let's see what's happening on the left side of this graph. Since my asymptote was at 4, negative 4, the first point I'm going to put in is x equals negative 5. Okay, let's do this. So it's 3, negative 5 minus 2 is negative 7, negative 5 plus 1 is negative 4. All over, that's going to be negative 1 squared, which is 1. So that's going to give me 84. So negative 5, 84. It's way up there. Doesn't help me much. All right, so let's start with the next point. X equals, I'm going to skip a couple. Let's go negative 7. Okay, because I want to get at least 3 points that I can graph over on that piece. But what do I do know? I do know that I'm going to be in this region of my graph now. Okay, I know where my second piece is going to be because of that negative 584. All right, let's do negative 7. So y is equal to 3. Negative 7 minus 2 is negative 9. Negative 7 plus 1 is 6. Negative 6. And then on the bottom, we have negative 3 plus 4 is a negative 7 plus 4, which is a negative 3 squared, is 9. So this is going to give me a positive 18. All right, that might fit on our graph now. All right, so let's see. Since we plugged in point, we're counting from the origin. So negative 7, positive 18. All right, so there's a point. All right, so we just get 2 more. We are done with this half. All right, I put in negative 10. I just went down a couple of values. There's no magic to the x's I'm picking. I'm just kind of trying to spread this thing out to see what's happening. All right, so let's do negative 10. So 3, negative 12, negative 9 on the numerator. The bottom I get, what, negative 6 squared is positive 36. All right, that reduces to positive 9. So negative 10, positive 9. All right, there we are. Okay, one more point. Let's do this. Let's do, and like I said, I wanted to figure out, I jumped pretty far down here. I wanted to see what's happening, how quick I get to that asymptote, and I'm tired of plugging in points. So I jumped to negative 20. All right. So y is equal to, all right, negative 20. What do we get? 3. Negative 20 gives me negative 22. Negative 19 over negative 16 squared is 196. All right. Which gave me 1254 over 196. And then that gave me about 4.8. Now, I'm okay if you use, just a 4-function calculator on this stuff. You've got to be able to do this without the use of a graphing calculator. Okay, so let's see what we got. We got negative 20. This was 10, right? Negative 10. So 11, 12. And then we got 4.8. All right, so that's a good choice. So that's going to give me that second piece of my graph. Whew, lots of work. All right, so like I said, when I see that perfect square trinomial on the bottom, the same factor twice, that's going to be like, okay, this is going to be one of those weird ones. Like, it's all about recognizing these patterns. All right, let's do one more for these notes. Here's my last one. Alright, so it's in my weird section, so I did go ahead and graph this on a calculator to show you what it looks like. Alright, let's talk about why. Why is that happening? Alright, so let's go back and look at the math behind it. Alright, so here again, I'm always going to start off by factoring. So my numerator is the difference of squares, but my denominator doesn't factor. There's nothing that multiplies to give you 9 and adds to give you 0 because there's no middle term. So here's what's making the weird stuff go on, because the bottom doesn't factor. So there's no common factor, so that's 0, or no whole. Not 0, there's no whole. There's no vertical asymptote because there's nothing that I can plug into, no real number that I can plug into the denominator to get 0. So there's no vertical asymptote. And that's that's where the weird stuff is starting to happen. Alright, horizontal asymptote. Our degrees match. So when we reduce that, we get y equals 1. Alright, x-intercepts, we do have zeros of the numerator. Okay. My y-intercept, plug 0 in for x. So my y-intercept is going to be negative 1/9. Okay. Alright, so let's see what we've got. We don't have a vertical asymptote, but we do have a horizontal asymptote at y equals 1. Alright, and now we can graph the points that we've got. So we've got what? 1, 0, and negative 1, 0, and then 0, 1, negative 1/9. So it's dropping down like that. Alright, notice this thing has reflectional symmetry. Let's do plug in 1 point because we need to figure out what's going on either side of this thing. So I picked the left side, so I used x equals negative 2 to figure out what's going on that left-hand side. Okay, so remember you're not going to have the benefit of seeing it on a graphing calculator first. So if we plug in negative 2, we're going to get what? Negative 3, negative 1 plus, I'm sorry, negative 2 plus 1 is negative 1, over negative 2 squared is 4 plus 9 is 13. So that's 3/13. Alright. So close to a quarter. So negative 2 and a bit. Okay. And so that's going to be this side. So that's why this thing is respecting those horizontal end behaviors, respecting those horizontal asymptotes. And it's going to look like this. Sort of kind of a weird parabola. Now you can do domain and range on this one. Okay, so our domain, alright, because this thing is symmetric, this is going to be our minimum point here. That drops down to, I'm sorry, my domain is my x values. Let's talk about the domain of x values. So it goes left and right, so that's all reals. But my range, alright, I've got an asymptote at 2 and a value here at negative 1/9. It includes negative 1/9, and it gets up to, I'm sorry, not 2, but 1, but we can't cross it. That's why that's an open parenthesis there. Okay, so that's lots of, like I said, some examples of rational equations, rational functions, graphing rational functions. And please, if you have any questions, write them down now so you remember to ask in class.